To geometry. First lessons that we start with, we call the building blocks of geometry. So it's pretty much in its title. So we're pretty much trying to set you guys up with some core knowledge and ideas of geometry so that we can hop into the important things. So you're going to start to see a lot of markings and labeling diagrams, how we can notate things symbolically, and then we'll be using them all year long. So we're going to start with points, lines, and planes, and we'll start with our basics points. So a point is a location. We show it with a dot. It does not have shape, it does not have size, and we notate it with a capital letter. So on the diagram given on this slide, I have quite a few points on it. I have point S, I have point T, I have point R, and I have point Q. Okay, so perhaps it's worth mentioning why it's important to label your points. Okay, so if I was to say to you, look at the diagram and locate point Q, you would clearly locate where I have circled. But if I gave you a picture like this and I had a bunch of tennis balls surrounded on a tennis court, and I wanted to pick an exact tennis ball for you to locate, it would be kind of tricky because I don't really have any labeling. I would, of course, be able to give some points of reference, like close to this line, close to the man's racket. But if the picture had looked more like this, I could very easily say to you guys, how about tennis ball T? So it's the same idea behind points. So we label them with a capital letter to be able to locate them the easiest and fastest way. Next, we're going to start talking about a line. So a line is made up of points. It has no thickness or width. It has exactly one line. There's exactly one line through any 2 points, and it will extend infinitely in 2 directions. It's notated with a lowercase cursive letter, or probably more commonly what we will see is with the 2 endpoints with a line symbol on top. So I have 2 lines on this diagram that we have here. The first line I'm going to mark in red. So this line here I can call line TR. Okay, the other line, which is passing through our plane, but we're not quite through that yet. Okay, has 2 endpoints on that line. It has endpoints S and endpoints T. Okay, it should be noted that TR, line TR, would be no different than line RT. Line ST would be no different than line TS. So kind of how you start the line doesn't really matter as long as you call it by its 2 endpoints. So I'm going to go back to this line here, that first line that I said in yellow. Okay, it's kind of hard to see the yellow, so let's try blue. Okay, so this blue line here, the only way I can name it right now is by its endpoints, but we said something about naming it with a lowercase cursive letter. From the diagram that I have right here, I don't have anything that gives me a lowercase letter to be able to name any of the lines, but that would look something like this if I wanted to put at the end of one of these lines, let's say a lowercase cursive L. I can also now refer to that blue line as line L. Okay, so the importance of why we label and refer to lines. So I have 3 lines here. I have a bunch of points on the diagram, okay? And I don't necessarily have all the points labeled. So if I did want to refer to this line in yellow here that I'm highlighting in yellow, okay, I do have 2 points on it. Only one is labeled, but it would be easy enough for me to refer to this yellow line by saying the one that passes through point O. However, if I was to give to you a few more lines on the same diagram, this line, let's say, is the one that I want to refer to. Okay, I can no longer really call it line that passes through O because I now have 2 lines that pass through point O. So now I would have to call this line OC. And if I said to you line OC, now you would know that I was referring to the line that I highlighted in red rather than the other one that passes through D, which would be called line OD. Okay. Oops. Okay, so let's start talking about a plane. Okay, so a plane is a flat two-dimensional surface. It's made up of points that extend infinitely in all directions. We notate a plane with an uppercase cursive letter or by the points located on the plane. Sometimes the uppercase is not always cursive, but it should be. So the same diagram that we've kind of been looking at here, the plane is this two-dimensional shape right here. Okay. It's most commonly shown with some kind of parallelogram, rectangular shape. It does not have to be a parallelogram shape. It's just most commonly shown with it. So this is your plane, and this would be called plane P. Okay, notice that could kind of be mistaken for a point, but because it doesn't have a point next to it, but yet it's just an uppercase letter that lies on the plane, that would be the name of the plane. So we'll call this plane P, and again, it should be an uppercase cursive letter, but they're not always shown by that. The other way to name a plane is by the points that are on the plane. So there are 3 points on this plane. So I could call this plane QTR, which would be the same as plane TQR, the same as RTQ, the same as RQT. But I would not be able to say plane SQTR. S is not on the plane. S does lie off of that plane. It is perhaps on a different plane that we do not know, but it is definitely not on the same plane as P. So despite the fact that it's on a line that has an end point which is on the plane, because S is off of the plane, we cannot name it by that point. Okay, so collinear. So it's kind of in the name if you take it apart. So often means same, okay, and linear being line. So collinear is same line, okay? It's 2 or more points that lie on the same line. So I have kind of 2 sets of collinear points here. I have collinear points ST here, and I have another set of collinear points here with TR. Okay. Something that sounds familiar, and there wouldn't be any like symbols or notation to know for this. Something that sounds very similar would be coplanar. Coplanar you can also take apart. Co would again be same. planar this time being plane. So now you're talking about 2 or more points that lie in the same plane. So QTR, all 3 of these points lie on the same plane. So Q, T, and R would all be considered coplanar points. Again, because S is not on that plane, S is not coplanar with any of those 3 points. Okay, so we talked about a line, and a line extends infinitely past its endpoint in both directions. That should not be confused with a line segment, where a line segment would stop at its endpoints and not continue in either direction. It would have its own notation. It would be notated with a segment symbol on top of the 2 endpoints. So what I have here would be segment AC. So instead of showing the arrows at the end of the 2 endpoints, I just simply stop it and say line segment AC. Okay, this would be the same as line segment ABC. This would also be the same as segment CA. It would also be the same as segment CBA. These are all equivalent. You don't have to name them, use all of them to name them, but they are the same. Now, if you were to refer to segment BC is simply from this endpoint to this endpoint, so it would not be the entire segment. Segment AB would be in blue, segment BC in red. The entire segment would be AC, or ABC, or CBA. Okay, so segment addition is something that we'll talk about. It's kind of self-explanatory, and it's used, but again, it's not something that we're going to spend a lot of time on, because it's something that's pretty easy for you guys to pick up on. So segment addition just says if there's a point that's in between 2 endpoints on a segment, that the one piece plus the other piece is equal to the entire piece. Okay, so in other words, the smaller piece AB plus the other smaller piece BC will equal the entire segment AC. Okay, so now if I was to tell you that from A to B would be 7, and I'll tell you that also from B to C is another 7 units, then we would know that the length of AC would be 14 units. Okay, so congruent. Congruent just means same measure. It's notated with a congruent symbol and markings. That symbol, the congruent symbol, looks like an equal sign with a squiggly above it. Okay, and the congruent markings are seen here in the diagram. Okay, so when you see 2 kind of tick marks on a line, that is showing that those 2 segments or those 2 lengths are congruent. They are of same measure. So if I was to tell you that AB was 5 units, then I would know that BC is also 5 units, because they're marked with 2 congruent markings. Okay. Another place that you could see congruence is on a diagram. So I could give you something that looks like a plane, let's say a parallelogram, and if I told you that this was congruent to this, you know that these 2 sides are the same measure. But let's say I have another pair of sides that are also congruent. Well, then I would want to show that also But if they are not congruent to the other two sides, I'm going to add another congruent marking to show that these two opposite sides are congruent and these two opposite sides are congruent, but that these two consecutive sides, here, 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 and here, would not necessarily be congruent. So I could give you a triangle and tell you that this has no congruent sides. I would know it would have no congruent sides because none of these markings match each other, as opposed to a triangle that may look like this, where I have two congruent sides that would be located in green here and here, and I know that because they both have single congruent markings. So let's just talk about how I would write some of these statements. So up top I have, I kind of wrote over it, but it was ABC. So I would want to say that segment AB is congruent to segment BC. That would be no different than if I was to say segment BA is congruent to segment CB. Okay. Similar to that is if I was to label this parallelogram with ABCD, I know that BC would be congruent to AD. And I would also know that AB would also be congruent to CD. Okay, I can, well, we'll hold off on angles because that is going to be in another video. Okay, so we'll talk about midpoint. So with midpoint, kind of the same as coplanar and co-linear, it's kind of within the word. It's a middle point. It's a point that's halfway between two endpoints on a segment. Okay, it cuts the segment into two congruent parts, divides the segment evenly. So because I know that these, well, because I now know that these are two congruent markings, we acknowledge that this entire segment here is being cut in half by that point, making that point a midpoint. So there wouldn't be any labeling for this. You can notate that it is dividing a segment by showing the two congruent sides, but there's no actual notation just for a, sorry about that, just for a midpoint. Oops. Okay, getting close to the end. So kind of a good follow-up to talking about a midpoint would be talking about a bisector. So a bisector kind of does something similar, only there are more things possible to be a bisector. So if something is bisected, it's divided into two congruent or two equal parts. So we would say that this segment is bisected by this point. Now we know now that that point's called a midpoint, but doesn't mean that it doesn't mean that a midpoint is the only thing that would bisect something. So for example, I could very easily put a line through that segment AC, and I could call that line, let's say, we'll do a script lowercase just to kind of see that on this video. We'll say that line D bisects segment AC, and I know it bisects because I'm given that it's split into two congruent parts. So I can also have had another segment that bisects it. Okay, I could call that segment DE. So again, I would know that DE would bisect AC because, again, I see the two congruent markings dividing it in half. So I could say that ED bisects AC at B. Okay. Now notice that I said that AC is being bisected by ED. So not that things have to be drawn to scale, but I'll make it look kind of the same. If I was to give you these markings, I now know that both AC and ED are bisecting each other. So I know that AC and ED are bisecting each other because I see that clearly both are being divided into two congruent parts. Okay, a ray. So a ray is kind of a combination, if you will, of a segment and a line. So it has one end point, but it doesn't extend infinitely in one direction. So here I have endpoint K, and it extends through endpoint J. So the name of the ray above would be KJ. However, it is not okay to call this JK. Okay, you always start with the letter that is the true endpoint, and you finalize the name of your ray with the point that it extends through. So I could see this called something else. So let's say I add another point to it. So now this can be ray KLJ, but it would still not be JLK. Okay. Another common thing that I see with rays are, if I give you AB facing this direction, you would call it ray AB, as opposed to ray AB here. This is still called ray AB. So the symbol on top doesn't imply any direction. It just simply tells you that it's a ray. It doesn't tell you that it points east, west, north, south, northeast, if you will. It just simply tells you that it is a ray with an endpoint where it doesn't extend through and the endpoint that it does. Okay, I think we're on our last one, which is an intersection. So an intersection you probably are familiar with, right? We drive through intersections. You walk through intersections of hallways, and where the main staircase meets the hallway would be where those two intersect. So it's where things meet, okay? And when we're talking about things, we're going to be talking about the points or lines where two or more things meet. So we'll be talking about intersecting planes, and we'll be talking about intersecting lines, okay? So on the diagram, I have quite a few things that are intersecting, but let's start with the lines, okay? I do have this line here, which we now know I could call this line MN, which would also be the same as MGN. I know that line MGN intersects. There's no symbol for intersect, so I'm just going to write it out. MGN intersects AGB. The point at which they intersect is the point that they have in common, so clearly they both have the G in common, so they intersect both at G. There is another line here that is intersecting those two lines, which would be line CD or CGD. So CD also intersects MN, intersects AB. So all of these lines, they all intersected at a single point. So it's important to know that two lines would intersect, or two or more lines would intersect at a point. You also have in this picture, and let me just kind of clear this out a bit. You also have a line that's intersecting a plane in this situation. You may have noticed on the first diagram that we were looking at that you have these dashed lines, okay? And they are important because dashed lines show that they're passing through something, okay? So I know that this line right here is definitely passing through this plane. Or is passing through something. And I also know that this line in red would also be passing through because I see those dashed parts right here, okay? But those two lines are passing through planes. So in blue, you can see that you have line CD or CGD, intersecting that blue plane there, which is K, at point G. Okay, so a line would also intersect a plane at a point. You also have this, you also have the red line, line AGB. Oops. Line AGB. Line AGB is intersecting this plane right here, also at point G. Okay. So there is another one right here in yellow, line EF. Line EF is, actually, is passing through plane K or intersecting plane K at B. And finally, you can have two planes that intersect each other. So two planes intersecting each other can visually be tough to understand what it looks like. I will demonstrate the intersecting of lines with a plane and intersecting planes with planes in class. This video is just to give you guys some background and some vocab. But I know I have two planes that intersect. So I kind of have this shaded plane here, plane L, okay? And then I have the unshaded plane, plane K. And I again see those dashed lines, signifying again that there is something that's passing through each other or intersecting each other. So these two planes would be intersecting each other. So two planes can intersect. Now, just like two lines would intersect at a point, and or a line and a plane would intersect also at a point, two planes would intersect at a line. So these two planes are intersecting at line MGN. Okay, so two lines intersect at a point. Two planes would intersect at a line, and one line and one plane intersect at a point. Okay. I do have a diagram to kind of show you, just to give you kind of an idea. So you could see that these are two kind of, let's say like a cardstock or a poster board, and they have, one is probably cut or both are cut in a way that you can have them pass through each other. But both of these would be considered planes because they are flat two-dimensional figures, and they are intersecting each other at this line. You could call this line line M. So this plane, let's call it plane K. And we'll call this plane here that we can't really see a flat side of plane T. So we could say that plane K intersects plane T at line M. And again, I'll show you a demonstration of it in class, all of the intersections, so you get a better idea of what that looks like. And that is it for our points, lines, planes video. Be sure to complete the notes that go with it. You could go back to fill in anything that you may have missed.